KTP, which is KTP is kind of knowledge transfer partnership. And this came into reality because we were able to work on scalability. Anyone can do, like we can fabricate material in our laboratories as professors, but how we can do it at larger scale? This is no way you can do it without an active, really work with QLife and bringing this at an industrial scale, do all the testing required to be able to register that. Because alhamdulillah, now this product is registered from the Ministry of Public Health, from the PDC department, which is equivalent to the FDA, Qatari FDA. So we are now in the phase of larger scale manufacturing after securing the registration. So this kind of a nanotechnology based product which contains silver at the nanoscale. I mean, like really small pieces or particle of nanoparticle that can fight bacteria for wound healing. So we did a lot of research to optimize our formulation, our non-particle preparation, the scalability, the stability, all the biological required testing, and we were able to assemble all these documentation, register that, and we are ready now to enter the market. And this was a stepping stone. This was a stepping stone toward applying for the KTP, and alhamdulillah, now we are also securing another grant. This was supported from the university, and I would like to thank here Qatar University for their generous support for research. So after we successed in this, now we applied for the KTP, and now we have more like bigger goal, Dr. Ahmed, to go wider now and add to our portfolio more nanotechnology based therapeutics in a collaboration between Qatar University and QLife. And I hope we did like a brief introduction of QLife and what we are doing.
Thank you so much. And what we'd like to do now is move to the next session, which is a panel discussion. So please, if you'd self, and Dr. Antonio, of course, please, sir. That'll be great to see you here. I will take the clicker. How do you go to the next slide? Next slide. Next slide. Next slide. Green. Right. Right. Thank you very much. Thank you for your presentations. Perfect. Just to introduce myself as well as we begin. My name is Amir Nahum, and I work at QRDI, supporting innovation programs, and specifically, I work on knowledge transfer partnerships. When we first launched knowledge transfer partnerships, or KTP, back last year, we were a little bit concerned at first. Will we find the demand? Will there be enough demand from the university side? Is there enough demand from the business side? And I remember, some sessions when we spoke to our colleagues here, and they were like, we are already working with industry, and we would love this. So today, really, we want to highlight previous collaborations on R&D between universities and businesses. I'm really happy that we have Dr. Antonio from HPKU, and thank you for your presentation. And also Dr. Ahmed, who, as well as being the CEO of QLife, of course, and part of the Shura Council, elsewhere as well. You have fantastic, vast experience within Qatar University itself as well. So you really bridge the gap between university and industry. And of course, Dr. Aladdin, who I think it's your 4th year in Qatar, I think, something like this. And you, previously in USA and Jordan, you've worked with industry to bring them onto, bring your research onto the practical side and into industry. So we would love to start with actually yourself, Dr. Aladdin, while we're here. We heard about the project. But I also heard, I remember when we first met, I was talking about KTP, and you put your hand up right at first. We were in a group, and you said, we're already doing this, right? We are trying to provide funding, but you said, we're already doing this. And so can you talk a little bit about your experiences working from the university with QLife and how that has been?
Well, thank you so much, Amir. You know, work like as an academic, you know, this is my like 15 years as academic. I'm a full professor at Qatar University. The way I look at it like translation and impact is our ultimate goal. We are doing research to address problem, to end up with solutions, to provide service, to leave an impact, to translate our knowledge into reality. So, in my philosophy, deep in my philosophy personally, the way I look at this is that industry is the lung I do breathe, you know? So I can do a lot of like experimentation in my laboratory. I can deliver a lot of talks to my students. But at the end of the day, if I want to do something real, something gonna come finally to the market, you know, I cannot do that without direct, real, effective, active interaction with industry. And the same thing, the industry, really they need us because Qatar is a very like developing fast, and they want kind of, you know, the R&D is the brain of any industrial business. You know, any industry, any factory need an R&D, research and development. By the way, I was working R&D manager in Hikma Pharmaceutical, which is the only FDA approved company in the Middle East, North Africa. And I kind of came out from the R&D. The R&D is the department where you design based on knowledge. So many like countries here in Qatar are just started. So they need industry, support from the academia to act as remote R&D for them. So we bring the knowledge, you know, as academic, like as people coming from all over the world, from different, you know, backgrounds, different expertise, and we kind of work with the industry as the R&D, and they will be the place we can translate our idea into product and services or solution.
Right, thank you so much. Yeah, and I think that is really important. There is so much value by university and business working together. The university is really at the cutting edge of research, and business have real business demand, and they know how to use that research, right? And this collaboration is really important. So, and Dr. Ahmed, with your previous, obviously, vast experience, especially within university, and then at QLife, obviously, how do you feel that? What are the benefits of the industry academia collaborations and then working together between business and academia?
Thank you very much. No doubt that industry and academia are integrated or linked to each other. Here in Qatar, of course, we you know, like universities started, and we have international universities here, and we have a lot of intellectuality coming from all over the world. So it's really good to, especially in industry, where you look at sustaining your strategic needs, or like in medicine. Medicine, of course, is very important to have it for the country. So you can use the intellectuality and come up with the new products. So here in Qatar, of course, seems to me that we are going in the right direction. And innovation is coming very soon, especially with the development in the technologies. Right today, we're talking about AI and other things, making things more easier to do. In QLife, we are in that direction. Of course, from my experience in Qatar University, I see that going for the real world industry is very important. And of course, it's not an easy, but always there would be success stories, and I see many success stories here for you know, benefiting from both academia and industry. So I think it's really a great road to that Qatar is embarking on this and encouraging research toward productivity and products, and I see it's coming very soon, inshallah.
Inshallah. Thank you, Doctor. And if I can ask Dr. Antonio, Or actually, I do want to have one follow-on question.
Yeah.
You have had past experience working with other universities as well. Is there anything that business can be doing more to engage with universities more? What can business do to engage?
Well, the thing is, business, of course, you know, especially we can say that we're coming to the industry very late.
Yeah.
Okay, but you know, we have to always focus on the elite things, because you may start with the conventional,
Yeah.
but you have to look at the elite to really
Yeah.
make success. So integration or and relation, having the industry exposed to academia is very important. I remember in 1997, I was the Vice Dean of Engineering that time, and I introduced that relation by having all the industry in Qatar, especially oil and gas companies, to come to the corridors of the College of Engineering and let the professors and students and industry communicate with each other. And that was really made a very successful, where our students from the university understand what's going on in the industry. So I think this is will be very important to let the industry communicate more to the academia and universities, of course.
Fantastic.
Thank
Thank you so much. And if I can move to Dr. Antonio, you have been recently awarded the KTP between HBKU, Kiri, and Agrico. But I know that your partnership with them has gone years back, right? Working with Agrico and others in industry as well. My question for you is, what are the main challenges in developing industry and academia collaboration, and how can these challenges be addressed? You know, that's the hard bit, right? It sounds great, but what are the challenges? Yeah.
That's the million-dollar question.
Exactly.
It's, you know, the main problem perhaps is to reconcile the potentially divergence of goals and objectives that the research, in particular academia and business have. So in the business world, you're basically trying to create wealth and profit to the creation of products and services. In academia, especially in academic research, the main objective is to create new knowledge, expand the boundaries of knowledge. And so if you take it at the extreme, these two things can lead you obviously in opposite directions. But you know, likely that is not what happens in practice for two reasons. First of all, because if you take business, you know, they have to, business has to focus on creating competitive advantage, and cannot do that by always doing the same things. I'm sure you're familiar with Christensen's wonderful work on the innovator's dilemma. You know, your clients will ask you to give you better products at lower price, but if you focus just on that, what happens is new entrants in the market will disrupt the market and you'll be out of it. So you have to focus on innovation. If you take academia, in order to really have succeed, you have to have social impact, and that's the point that you guys were making. And in order to do that, you have to bridge from theory to practice. And again, innovation is the basic point where these two things come together. So, you know, to make to sort of put the two things together, I think that innovation is really the locus where academia and you know, business can come together.
How about, I know that with time we're running about 5 minutes, but what policies or incentives can be developed to further support, quite briefly, if you don't mind, these collaborations?
Well, there are a lot of things that you can do. You know, so for example, one very important thing, and this is something that we've done in Kiri, HBKU, is the creation of institutional test beds.
Yeah.
So these are, so for example, in KIRI, with the Qatar Environment and Energy Research Institute, we manage a 34,000 square meter facility, which is next to the Qatar Science and Technology Park building, next to QNCC. And we have a lot of different technologies there, from renewable energy, water research, and environment. And it's a place where academia and industry can come together and test and develop new products. If you look at the more regulatory side of things,
Right.
I think it's very important to have add the clarity to intellectual property ownership,
Right.
because this is very important, especially when you go to market. Who's going to own what and how.
Yeah.
And there are things that you can do to facilitate. So, for example, an idea is to have some sort of tax
Yeah.
incentives for industry that engages in collaboration with
Right.
the university.
Thank you. Thank you so much. And just to lead on to that, Dr. Aladdin, you have experience at the university side in the States, in Jordan, and then here, and also working on the business side as well. For businesses considering a KTP partnership or any collaboration with a university, what can they do or advise to ensure they maximize the value of that collaboration? What can businesses do to maximize the value of the collaboration?
Well, my advice is two things. The first thing, we need really more kind of altering the mindset of the industry.
Right.
In part, the poor collaboration between industry and academia due to the absence of awareness or knowledge that we can work together and we are complement to each other, and there is a lot of things in the university that can be really a big wealth for us.
Right.
This kind of mindset, because I start my academic career after, I'm done with the industry.
Right.
When I was in the industry, I was with a big industry, honestly. Like it is as I mentioned, it is the only FDA approved company in the Middle East. So we were doing manufacturing in Jordan, selling in the US. So all the United States market is kind of open for us. So the way we were looking at the industries, the universities, that they don't have too much to provide.
Yeah.
So these guys are professors, they are teachers, they are lecturers. Maybe they are not, they don't know the language we speak here in the industry, which is absolutely wrong, definitely. So this is my first point, which is the mindset. We need really to work on that. And again, this is my third time to thank you. Really would like to thank the KTP, because the KTP here in Qatar, I think this is the first call to bring these two guys. It's not the first to bridge this collaboration, but to work in it in this kind of style. The other thing is for the maximization is to do not just a mindset, is more opportunity of interactions. So the universities should work from their end strategically at supporting their PIs or their professors to go more translational, more impactful. It's not like for me as a leader in any university, I will not accept anymore just want to do in research which will not end with something will address a real issue. So we need to work from the mindset to more the strategic plan at the actual more events to collaborate and meet and talk and know each other, looking and fishing for opportunity to work and to team up.
Thank you, Dr. Aladdin. I want to give the final word to Dr. Ahmed. This has been really insightful. I think we can talk for a lot more longer as well. But just to finish off, Doctor, because I think we're just running out of time. From a Qatar side level, what strategies or policies should from Qatar, from a national side, should we be implementing to support these collaborations between industry and business? Quite briefly, and then we can wrap.
Thank you. I think right now Qatar, of course, as you see, the changes is happening, and now going on the right track where in regard to for R&D and collaboration between industry and R&D, there is a new legislation that's going to be very soon available, and decree as a law that's gonna be approved in Qatar for that purpose, so for innovation and research. So that's really encouraging the industry and also academia to benefit from this thing. So I'm sure, as you know now, when you go to any industry in Qatar, you may not find R&D slash R&D. But of course, in our facility, because we are in pharmaceutical, we are a laboratory before we are industry.
Yeah.
So, but I visited one time in Korea, South Korea. Even small factories, they have R&D. And I asked the guy, so what do you do? He said, they're doing something related to efficiency of plates, metal plates. So this indicates that how there is a complete, a closed loop between academia, research, and of course, Qatar is setting a good part of its revenue from hydrocarbons for the diversification of economy. So where we are going with that, of course, with this KTP and QD, RDI, all this is gonna help and enable to be considered to be one of the innovating countries in the world, inshallah, in the near future.
Thank you so much, Dr. Ahmed. And we come to the end, and we'd like to thank all of our guests. One small point before we go, for those interested in knowledge transfer partnerships, either if you're in university, academia, or as a startup or a business or a large enterprise, definitely give us a call or send us a line and we can get back to you. But really, thank you so much for our guests. This has been incredibly insightful, and wish you all the best of luck in the projects, these individual projects, and I'm sure it will go from strength to strength. So thank you. Thank you. Thank you. Thank you.
Thank you.
Shukran. Thank you very much. All the best. Thank you. Pleasure meeting you.
Nice to meet you.
Thank you.
نحن على كوش كون بحذاك تستحق أي شيء كلمني.
Possible questions, we'll open the floor.
Yes.
Test. Test. Test.
اوكي
Test.
طيب ماشي اوكي تمام
Just to show you very fast, if you want to go to the next page, you have to make a presentation. This one. If you skip a page, go back to this. If you want to highlight something with a laser. Yes. Please, let's start. ترجع اللي قدام الأحمر تمام. هذه لا عادي يعني لما عشان تستخدم الليزر لازم
لا لا البريزنت عادي
Let's have our seats. We will be starting in a couple of seconds. So, good afternoon, everyone, and thank you for joining us for this exciting session about the lab to the market, the PhD pitch presentation. Actually, this session is very close to my heart because it culminates all the efforts and investments that we have made in talent and research all the way from K to 12, high school students, and now PhD researchers. And why not even today, a step closer to market-ready labs. Many will say that scientific research is the longest road to innovation, but it's also one of the most rewarding journeys. Actually, when doing scientific research, you will have a lot of challenges, risks, uncertainties, but still, till date, it's the most reliable tool, I would say, to answer our imminent challenges. Also, usually our PhD students are trained to become researchers, scientists, join the academia. However, through such session and similar activities, we're hoping to shed light to a new but still very exciting career path linked to industry, entrepreneurship, and innovation. Today, I'm really glad to welcome three of our most talented PhD researchers who will each take us in a different direction, from environmental sustainability to water security to public health. I really hope that you will engage, ask questions, and help us linking research to innovation. We will start now with our first presentation. Join me in welcoming Ms. Aisha Rumaihi, who will be discussing about an innovative way to produce biochar. Aisha, the floor is yours.
Hi everyone, Assalamu alaikum. I would prefer presenting while standing, if it is okay with everyone. Okay. Before I start, I would like to introduce myself. My name is Dr. Aisha Rumaihi, and just before we start, A bit about me. I have graduated from Qatar University in Environmental Science. Then I've worked in Qatar Energy for over 16 years now in the oil and gas industry. And then I decided to continue my PhD and master at Hamad bin Khalifa in sustainable and energy. And then I've took multiple training programs. One of them is from Qatar Leadership Center. And then I've been also representing the state in multiple national and international conferences from LADAM Youth Ambassador, as well as I was part of Shura Council program this last year. And I've been also awarded for one of the Sustainability Heroes in 2023. With all of that and being active in the field of sustainability and technology, I've been also active in the entrepreneurship. I have my own bakery, which was started since 2014. It's my own passion. It's called Delicious. However, in today's presentation, I'm going to be discussing about part of my PhD program, which is discussing about the technology to manage solid waste, to produce biochar, which I'm going to talk about later in details, but I'm going to be trying my best to make it simple for everyone to understand it. With that being said, I will first give a brief introduction. What is the problem that we're suffering from in terms of waste management in Qatar, and why this technology is beneficial, and how it's going to help us, leading us to the methodology, results, and conclusion. So, as we all know that there is an increase in the population in this coming years. With an increase in population and an increase in the GDP, it means that people will tend to consume more resources and hence producing more waste. And as a result of that, new emerging technologies to manage waste is important to reduce climate change and protect the environment and the economy and the society as well. Not to forget that the global temperature is also increasing and it's causing high GHG emission, climate change, as well as the sources of fresh water is expected to decrease as well, which will impact the agricultural life and impacting also food and water security. The other problem is the carbon footprint of plastic, which is the most abundant plastic type of waste that is generated in Doha, expecting to increase in terms of the carbon footprint by 2,800 metric tons per year. And we cannot neglect the impact of plastic waste on the marine life and the environment as well. So how the pyrolysis technology works in order for us to understand how it's going to help us in this situation. So it's basically a complex multi-step process in which we will disintegrate the solid waste into other products. So basically you will have the waste, whatever waste you have, and then you will grind it, you will dry it. It will go through a biochar reactor. From the biochar reactor, you will yield into basically three products. The first one is the char, which is the one we are targeting. You will have the gas, it's called syngas, and you'll have oil, which is called pyrolysis oil. So why we are focusing on biochar? Because biochar is going to be applied to the soil, just like a fertilizer. So once we have the biochar, we don't have to consume resources to produce artificial fertilizers, number one. And then number two, it's going to add benefits to the soil. As we know, Qatar has an arid desert climate, plus our soil is sandy and is suffering from numerous issues in terms of water infiltration and low amount of nutrients. Aside of that, we only rely on desalinating seawater as a fresh source of water for irrigation, which is quite a problem. And having the biochar is going to solve all of those issues. So what is biochar? It's basically a unique carbon-rich product that uses domestic and industrial waste to be produced. And how it's going to benefit the soil? Basically, first, it's going to improve the soil. and enhancing its nutrition and fertility, as well as increasing the carbon content in the soil, which will help in retaining the water. So you will not have to irrigate the soil frequently because it will contain the water and the plant will get use from it. Aside of that, it will enhance the pH, microbial biology, making the plant growth most faster and efficient. And it has been actually produced in laboratory. We produced it and we compared the artificial fertilizer with the biochar. We noticed a significant plant growth in comparison. Not only that, it will also benefit the environment by reducing or locking the GHG emission into the soil, preventing it to go into the atmosphere. So these are some of the benefits. However, the proposed waste that we are planning to study is 3 types. The first one is plastic. Plastic, we decided to study low-density polyethylene and high-density polyethylene. The difference is the low-density polyethylene has been used in cling film, wrapping, the low material of plastic, but the high density is used in plastic bottles, shampoo bottles. And why we studied those type of waste or those type of plastic? Because it's available and we use them daily and we discard them. And the second type of waste is camel manure. We know that Qatar has lots of camel farms and it's a home of 127,000 camels, which produces a lot of manure. Not to forget that the manure is rich with nutrients that's beneficial to the soil, so it's gonna enhance the quality of our biochar before we apply it to the soil. And then the third and the final feedstock or type of waste is the date pits. The date pits is rich of nutrients as well that is beneficial to the soil. Not to forget that Qatar produces a lot of dates and we have lots of date farms, which they tend to produce a lot of date pits. And it's been also collected to produce other stuff such as coffee beans and, you know, but in this case, we are trying to use the date pits to utilize it to get benefit from those nutrients, specifically to enhance the biochar quality. So we studied the technology in terms of the environmental impact, in terms of energy, best energy source to be used. We also analyzed the technology economically, socially. So we studied all of those aspects, but due to this shortage of time in 10 minutes, I will only cover one part where we have invested into using a Aspen Plus software. It's basically enabling us to study the mechanical and the physical properties of these feedstocks on how they will interact with each other before we go to the lab scale. And what type of biochar they're going to produce. Is it going to be a good quality? Is there going to be several interactions that is going to prevent us from producing that biochar? So all of that have been studied using Aspen Plus, which is a modeling software. And then in addition to that, we want to study what was the best mixing ratio. How much we should mix plastic to camel manure to date pits. How much the percentage of mixing that will enable us to produce more char than oil or gas. Now, producing oil and gas is good, but for the state of Qatar, we do have a lot of oil and gas, so we don't need that. It may be an option to think about in the future, just to diversify the sources of energy, because we have a finite source of energy. However, in this particular scenario, we're focusing more on the biochar. So our aim is to know which mixture that will produce more biochar, and what are the parameters, such as the pressure, the temperature, that we can use that will produce more char at the end of the day. So, first of all, I accumulated different kinds of waste from different farms. I went to the laboratory, I used the TGA, we grinded them, we dried them, we determined the moisture content. It's important to know the moisture content because before the waste is being treated, it has to be dry. The percentage of moisture must be less than 5%. Otherwise, we're going to produce more gas, which is something that we don't want, which is why we treat it. We treat the waste before it's being analyzed. And then we studied also the content or the elemental content, the CHO and N and sulfur content. Just we want to know how can the elemental composition of the waste can impact the end result of the char itself. And then, so this is basically the model development. We studied a range of temperature between 300 to 600 degrees at the beginning. And then we used Ben Robinson property for physical property because it has the mechanical equilibrium. And also we have determined the enthalpy and the density for the biochar equal as to coal in the software itself. This is just basically a diagram to describe the process. So at the first stage, you will have the dryer where the waste is gonna, feed is gonna go to the dryer. So you will have the feed and you will have water. And we were thinking of also how to polygenerate and reuse this water for other purposes for irrigation. And then once the feed is separated, it's gonna go to the yielder where it's gonna be yieldified and pyrolyzed to produce solid and liquid material. The liquid material will be separated into gas and oil, while the solid material is gonna be separated into char and ash. So that's basically the whole diagram of the process. The results shows that at higher temperature, like at 600 degrees Celsius, we will get more biochar, specifically using the blend mix and having more plastic into the mixture of waste. And after analyzing, we discovered that because plastic is made from bicarbons, so it has carbon a lot in its structure, so it produces a high carbon content biochar. While for the gas, it was produced at high temperature as well when mixing only camel manure and date pits. As for the oil, at low temperature, it was producing high amounts, specifically for manure feedstock. And this will bring us to the conclusion. Overall, the technology was very beneficial. Many countries studied this technology and they have implemented it, not necessarily for char, which is a gap, and not necessarily for the state of Qatar. Most countries have been implementing this technology, but in China and India, for the specific type of waste they have and for the specific type of soil that they have. So having this technology studied is good. You can see a pilot scale of this technology in Qatar Foundation Educational City and Green Island, which has been already done. We are also planning with a bunch of faculty members from HBKU to do one of the largest pyrolysis treatment plant in the Middle East coming soon. And this will bring us to the end. Thank you. This is my Google Scholar page if you want to read more about this technology. And that's it. Thank you.
So thank you, Aisha. I will open the floor for one questions or two. If anyone has a question.
Dr. Asha, thank you for the wonderful presentation. My question is about the economic feasibility of the study. So you mentioned that you were going to use plastic and possibly camel manure and then insert that into a machinery where it's going to produce biochar. So is there an incentive for industries to go and use that rather than use regular fertilizers?
So we did the life cycle assessment of the whole process, like from collection of those type of waste until the assumption of where the plant is going to be located using a GPS. And then we also assumed if it was going to be delivered to the end consumers. So overall, we have estimated like the place of the treatment is going to be in Said Industrial City, which is far from the residential area. Due to the odor, number one. Number two is that it's in the middle. It's easy of reach to collect all of the type of waste. Mainly, the emission comes from the transportation itself, more than the process. Because during the process, you will have some biogenic emissions. So it's not as But economically, it is economically feasible if you will, because you calculated the capex and the opex of the overall project. It's what already economically feasible. So whatever we're going to invest in this project is going to yield in the more benefits in the product and the outcome. But what we need more is how to market this kind of product, to make it, you know, available for the end users and convince them of why they should use that than other products.
Is it possible to ask another question?
Go ahead.
Thank you very much. This one is more about your career. So you mentioned that you worked at Qatar Energy for about 16 years, and then you decided to go ahead with a master's and a PhD. Regarding your work at Qatar Energy, did anything change after you obtained those 2 degrees?
Well, I decided to study my PhD in sustainability specifically because I was assigned in Qatar Energy to do the sustainability reporting and sustainability projects. So I was in charge of all of that. It was just recently generated as a concept. And I saw the PhD program at HBKU. So I was like, it's going to broaden my knowledge. In terms of producing, you know, energy, which is hence this technology, it's producing energy from waste that we don't use. I was kind of wanting to propose this project to Qatar Energy to invest in it more, but Qatar Foundation, they came, you know, they attacked me. They said, we want this, we will adopt it, we will help you with it. So maybe in the future I can use the background that I have gained in my PhD program to have more innovation and producing more technologies that can help Qatar Energy in the state of Qatar. And working in Qatar Energy, they will have them as sponsors for sure, inshallah, in the future.
Thank you very much.
Thank you, Aisha. Our next speaker will be more involved in underground water simulation and filtration. Please join me in welcoming Dr. Jamal Hanoun, who just, by the way, completed his PhD a couple of months ago.
Thank you, and Assalamu alaikum, everyone. Can you hear me clearly? Okay, so I am Jamal Hanoun. I'm a civil engineer. As Dr. Ayman said, last month I completed my PhD in environmental and hydrological engineering. The work that I do is basically about enhancing Qatar water security using 2 technologies, microtomography and microfluidics. Can you hear me? No. Yes? Can you hear me? Can everybody hear me clearly? Okay, great. So let's start it. So around the world, there are about 4 billion people this year that live in water-stressed regions. And Qatar is among the world's most water-stressed region. The natural rainwater in Qatar, which are the only water source, can only sustain 10% of us. So the rest will not have any water to drink. That's why we rely on desalination. So to assure water security, we need to store a lot of water. And Qatar have already invested billions of dollars in building the world's largest water tank. But I want to ask you a question. Do you know the world's largest water tank will have enough water to sustain us how many days? Anybody would guess? 7 days. Only 7 days. These are the largest water tank anywhere in the world. After that, what we will do, we'll go back to what our grandparents used to do. Dig a water well and pull the water from that. Yet, if we did that in Qatar, we'll have water to sustain us for only 30 days. Now, to assure water security, the 2030 sustainability vision want to increase that to 90 days, 3 times. And we can achieve that by collecting more rainwater. Currently, we are able to only store 5% of the rainwater. The target is to increase that 3-fold to increase the amount of water stored under the ground. But there is a problem, as always, and we need engineers to solve it. If we store this water, we might ruin the water aquifers because this water have different salinity to what we have under the ground. So
a problem will arise which is named fines migration. Small dust particles will start moving under the ground and blocking the flow. So we need to solve that as engineers. This is a really nice visual to show us a well that is being dug. And here a zoomed view. Inside of the rocks, there are a lot of pores. And inside of these pores, where actually water or oil or gas is being stored. What we want to do, we want to dig wells and we want to pump water and we want to store it. And whenever some farmer, for example, needs to pull water for his farm, he can pull that water. Or, for example, if God forbid the desalination station stopped working, we can use these water to ensure our water security. So it's very crucial for us to recharge rainwater in Qatar. And this recharge must be done in a way that is sustainable, that does not damage the aquifer. Now, fine migration is a double-edged sword. We can either do it in unscientific way and let it ruin the wells and ruin the aquifers, or we can engineer it in a way to help us increase the amount that we can store and make it easier for us to pull water and use it for drinking or irrigation. The image that you see right here is a real image, a real sample, where you can see these fine small particles, and here it's segmented in red, it's labeled, and we can now for the first time in science and in history actually investigate this, and I will take you now into the journey of that. So I said at the beginning, microtomography and microfluidics. Let me introduce you to that. So microtomography is a non-destructive scanning technology where we take samples and we construct the 3D structure of it. And by the way, you will start seeing tomography setups in every part of your life. If you now will go to a hospital, they will scan you using a 3D scanner. Even your package at the airport, they will convert it now to a 3D tomography. So we use the same technology. In our case, we go to the most advanced facilities in the world. We use in the US a synchrotron facility, which is called Argonne National Lab. And recently they opened one in Jordan. And we use these facilities to scan real rock samples. So what you see here is part of a rock that is being dug 60 meters deep. We take small samples and then we do the CT scan for it. And I'm very proud that because of the work I done in my PhD, these two facilities now offer Qatar researcher a free access for anybody from Qatar that want to use this facility. So the results that we will get from these scans will allow us to reconstruct and see the details inside of the sediments, inside of the rock, measure everything that we can measure in a lab, but all digitally. And we can see the fluids and the liquids and the gases. And also what we did is we developed a way to see this fine migration that we are really concerned about. Also, after obtaining these images, we can generate something called a pore network. When we talk about hydrological or reservoir engineering, the radius of the pores is the most important factor to control the pressure, whether to produce water or to inject water. And this will allow us to go from like small microscopic scale to a kilometer reservoir scale. The image that you see is 160 gigabyte in size. Using this technology, we convert it to less than 1 megabyte in size. So it's a huge computational saving. And of course, the structure of this reservoir is very variable. So we did a lot of study on different type of rocks and sediment. And the most important thing in our work is that the sample is representative. We need the size of the sample to be representative. So we selected the minimum size that we can work with. And smaller than that size, the sample might change, the measurement of the sample might change. But we chose the size for each sample that is that achieves the smallest representative elementary volume to allow us to see more details of the sample. And because of that, for each sample and for each case, we'll have a different testing and experimental setup. So part of the creation from my PhD work is actually to create or invent the world's first 3D printed core holder to do this experiment for 3D scanning and for fluid studies and injections. And I created a full assembly with the seals, and everything was 3D printed. Anyone in the world can buy it and print it in their home, using their home 3D printer. And of course, we had to test it using at the synchrotron facility, and the results were mesmerizing. Another part of the work is actually developing a pump that will achieve the targets that we need to increase the amount of stored water, and we develop this pump from cheap 3D blasted parts and from construction equipment. And these are some of the first results, and we can see these finds and track them as they move. And one of the discoveries, we found that we can increase our ability to store water by 30%. And this is a raw image and one. And here we can track the movement of fine particle and engineer this movement to make sure that we flush the fine, but we have a stable reservoir in the subsurface. Because if these parameters are not engineered, fractures and vugs can start to form, which is not stable and can have many risks when working with groundwater injection. I will start moving quickly. Yes. Yeah. Okay. So now I will jump to the second part of the presentation, which talks about microfluidic devices. So using the geometry from these scans, we developed the first microfluidic devices that allow us to study fines migration and multi-phase flow. And these replicate the real geometries and will and allow us to see discoveries on how fines, for example, can start disconnecting the air and water and affect our water production or storage. We also developed AI models to automatically segment from the microscope and have it directly to the computer model. And also, we worked on the very basic fundamental level. There is an equation called DLVO equation, and this equation describes this fine particle attachment. We developed a code for the first time to solve this equation, and people in medicine, people working on different fields can use this code to actually calculate these interactions. Our future work in the next step will focus on these. These are the gems of our work. What you're looking here is the first tomography synchrotron-based images of Qatari rock, and we will be doing our digital simulation on it. At the end, I would like to acknowledge the support that I received from QRDI through my JISRA grant. Hands down, this is truly the best research support team anywhere in the world. I've went to conferences, I've met a lot of people. I really appreciate their support. I support the synchrotron facility and Qatar University. Just at the end, whoever like to scan this code and have the 3D model on his phone can have